Guys, welcome back to the channel and to another video. In this video we're going to do some balancing one more time, and let me just show you what we're balancing. Alright, so this is what we're balancing. This is a shaft. The customer says it's from a shredder. So the blades of the shredder gets mounted on this face here, and they are adjusted by that 6mm bolts in there. So the blades are slotted, and they obviously go in here, and then it gets adjusted. So there's 3 blades to each shaft. So my job is to balance the shaft just to see how much is out, and obviously if it's out, balance it within. And it seems like it's the first time I'm doing something like this. This is something totally new to me, but it seems like I'll probably have to do the double plane balancing, similar that I do to the vacuum elements, because I'm going to run the one roller there and the other roller there. So this is within, and let's see how unbalanced these are. Let me just get the weights and take some dimensions of this thing and get the ball started. Alright, so this unit weighs 9.815 kilograms. Not too bad. Let's write this on the board. Alright, so I needed to determine this diameter of this thing. So I put this straight edge on like that, as you saw, and I took a vernier from the top of the straight edge to the bottom of the shaft here. So all I'm going to do now is take that size, deduct this from it, and deduct half of this from it, and that will give me that throw. So then that will be more or less the diameter of this cam. Okay, I'm going to do that measurements now and put it on the board. Well, not measurements, sorry guys. I'm going to do that calculations now and stick it on the board. Alright, so this seems to be normal mild steel, probably like a hardened mild steel EN19 or whatever, I'm not sure. But it's definitely mild steel. It's not cast. I can see on the threads, and I can see here where it chipped off and stuff, and dents is not cast iron. So this is definitely mild steel. So let's just say steel density, mild steel is 7.860 grams per cubic centimeter. Okay, I think this might be all the data that I need until I put this on the machine. So let's set the machine up, stick this on, and then get the A, B, and C's of this shaft. Alright, before I even do that, let me take these bolts out here. The customer said I must take these bolts out prior to balancing. Let me just do that quickly. Okay, they're all out. Let's stick that on the machine. Alright, so I got this set up just so rough, and I'm going to put the shaft on now just to make sure everything is more or less in position, and then I'll tighten all these cap screws as it should be. Alright, so I got it on. I actually tightened all these cap screws up so the bearing posts are all sorted out. You can see there she's spinning more or less. So now I'm just going to put the end stops on both ends, put the belt on, and then start testing. Alright, so I got the machine on. I got my pickup eye thing there. So I'm just going to turn it just to make sure that she actually reads it. Okay, so the reflector tape is coming now. Let's just see if it flashes. Yep. Okay, so she's definitely picking that up. So what I'm going to do now, I'm going to just turn this thing very slowly, oil the bearings, and set the adjustment. Alright, so I got to turn in very slowly. You can see it's touching there, so she's not exactly set properly. I'm going to just set this thing properly off camera now, and I'll show you when it's all set. Alright, so I just turned it on that adjustment screw there to get it off that bearing. So it's slightly too much this side, so I'll just like jack this side up a little bit, and then I'll put all the data in the machine, and let's see what she looks like. Right, it's time for me to calibrate it. So there I got shredder shaft, bearing 1. I'm going to balance it at 1000 revs per minute. A is 68, B is 148, C is 90, radius 59.5, and that's all the different tolerances given for the shaft. Anyway, so I'm going to just do the calibration now. Alright, so at present she's running at 588. Earlier on when I took it a bit higher, she actually started bouncing, so I think the unbalanced is I think the balancing speed that I want to balance this at is a bit too fast for this unbalance of this thing. So I'm actually going to turn this down. I'm going to make this balancing speed 600. I'm going to do that off camera and I'll get back to you. Alright, so there I changed the speed to 600 in the parameters to calibrate. I think it makes me a little bit more comfortable at 600. Because when it was, like I said, when it was going to 1,000, the thing was made a bit of a rattle. So anyway, let's carry on with the calibration. Alright, so let's put the weights in. So the putty was 4.78. 4.78. That's okay. The degrees that was on was 0 on the left plane. On the right plane I used the same putty, which is 4.78 grams, and the degree there was 0. Okay, so you can see the speed is 600. She's 25.84 out at 107 on this plane here, and 22.34 at 210 on this plane here. So okay, let's just stop and print this. Okay, so there we are. Shredder shaft, that's the mass of it. All the details. This is unqualified, so I must take off some mass on the left plane and take off some mass on the right plane. Right, let's start the process. Okay, so this is where I must drill this hole, and on this one, this is where I must drill this hole. So I have a choice. I can either drill the hole or I can grind this area here. So what I'm going to do, I think I'm first going to drill a hole. This is an 8mm hole, and there as well, and then see how that affects the balance. Alright, so I drilled 2 holes instead of 1. Same on this side here, 2 holes instead of 1. I made it 4.5 deep this side and 4mm deep that side. So I'm going to just run the machine now. Okay, that should be good enough. Okay. Alright, you can see I came down to 17 and 16, whereas this was 20 something before, and both was in the 20s before. So I think what I'm going to do now is I think I'm going to just drill these holes a little bit deeper on the same spot and then just see what happens. Alright, so I went deeper down on those holes. Let's just see now what the result is. Okay, let's just switch it on. $292. Let's just speed it up a bit more. 294. Okay, there we go. Alright, okay, so she's down to 10 and 9, so we're definitely coming closer. So I think what I'm going to do is I'm not going to, let me just switch this off quickly. Okay, I think what I'm going to do, I'm not going to go deeper now, because I don't want to, like, although I'm still far from this hole, and I'm still actually quite far from that hole, I don't want to go any deeper. What I think I'm going to do, I'm going to go bigger on the diameter now. Now I don't want to go, it doesn't really matter if I go off the edge, but I want to go bigger on this diameters now. Yeah. And then let's see, I can at least go 13mm or something to that effect. I might go just a smidgen deeper and then go bigger. Alright, so she's back on the machine. As for the holes, I didn't go bigger yet. I went deeper though. So these are now 10mm deep. That's 10mm and this is 10mm deep. So I just want to see what effect that has on the balancing, and after this I will go bigger on the diameter of the holes. Okay, so let's just start the machine up quickly. You can see now she was at 10 and 9. So let's just start and see what it does. Okay, so after that round of drilling, you can see she's down to 3 and 4, so she's almost there. I'm just going to increase the size of those holes, and then I think we should be quite close. Stop this quickly. We'll just show you again there. That's what I meant. It's now 10 millimeter deep. So if I increase the size of the holes, I think we should be relatively close to that. Alright, so we're getting closer. That side is acceptable, and this side is almost there, so let's keep on working at this thing. Alright, I've got the running again here, and you can see she's on 600. She's 0.28 and 0.66 out of balance here, so this thing is 100% perfect. Let's just stop this and print this quickly. Just press enter, and let's just compare this to the unqualified one. Alright, you can see there she's qualified, there she's unqualified. We started off at 25.84 at 107 degrees, that was out, and we started here 22.34, which was 210 degrees out, and we got it same data, qualified down to 0.28 at 35 degrees and 0.66 at 228 degrees. I could bring this closer, but it will be useless because when they put the blades, let me just go back to the thing quickly. Okay, like I was saying, I could have brought this closer, but when they put these blades in with these bolts, I mean, if this bolt, for argument's sake, is 1 millimeter longer than that bolt, and that bolt is 0.3 or whatever longer, and then the blade itself, and then plus the adjustment here, if this bolt here is 20 mil out and this bolt is 18 mil out, which means the centrifugal forces on this one would be greater than this one, then this will be out of balance again. But for this assembly like it is now, she's relatively balanced. You can see I grinded a bit there, and I drilled again a bit deeper inside the holes. This side I didn't have to drill, this side was actually quite good. This side I just had to grind a little bit there to make this all good. So yeah, this one is good to go. Alright guys, so that's me ending off this video. I hope you found it entertaining and exciting. Also, this is me ending off the year as far as videos go. So I'd like to thank the new subscribers for subscribing to the channel. Welcome to my channel. I hope you enjoy it. To all my Christian people, or the people that celebrate Christmas, I'd like to wish you and your family a very Merry Christmas and a very prosperous New Year. Across the board, I'd like to wish everybody a very safe festive season, and I hope 2025 brings you on to greater, better things. Out with the old, as I say, in with the new. So enjoy the rest of 2024, guys. Keep it safe. I'll catch you in 2025. Cheers for now.